In today's video, I will talk about quadratic function. So in grade 10, we have learned linear function. The graph of linear function is a straight line. And starting from grade 11, we're going to learn curves. So the simplest quadratic function is fx equal to x squared. And the graph is very simple. The name of the graph is a parabola, like this. So we should consider the effect of parameters of a function on x squared. So for example, if we times value a on x squared, when a is 0.5, we can see the graph become wider. And when we times -3, the graph become a reflection and become narrower. So here we can summarize as the parameter A is determining the orientation and shape of the graph. When A is greater than 0, it's open upward, and A is smaller than 0, it's open downward. And when A is smaller than 1, basically the parabola will become wider, and when A is greater than 1, the graph will become narrower. And second thing, we can consider the effect of parameter of Q when we plus a constant Q here. So for example, when we consider the graph of x squared plus 5, so we can see the point 0, 0, 0, 0 will become 0, 5, right? So become 0, 5. And then the point 2, 4 here, 2, 4 will become 2 and 9. So basically each point on the original graph will move 5 units to up. So the same thing happened here. -4 means down 4 units. So parameter Q translates the parabola vertically Q units. And the third thing, the last thing we consider here is the effect of parameter P if we minus a P with X. So it's just from X squared to X minus P squared. So for example, we consider X minus 1 squared. So the original point 0, 0 will become 1, 0 if we control the y value doesn't change. And the point, for example, 2, 4 here, if we want to put the y value the same, x value should become 3, 4, right? Because 3 minus 1 squared is equal to 4. So that means actually each point will move 1 unit to the right. And the same thing, -3 means 3 units to the left. And so here the point 0, 0 will become -3, 0, right? So that means parameter P translates the parabola P unit to the right or left. So X minus P means P unit to the right. So in summary, the standard form of a quadratic function is this. We have a power of 2. And the graph of the quadratic function is a parabola. And we have a vertical line called axis of symmetry. And the parabola is symmetric with the vertical line. And we have a point that is vertex. And it's open upward when a greater than 0, and open downward when a smaller than 0. And we have x-intercept, y-intercept, we have to decide the domain and range, direction of opening, maximum value or minimum value. So here we will talk about from the function in general form into this sometimes we'll call vertex form or standard form. So we will use a skill called completing the square to rearrange this form into this form. We will talk about completing square later, but here you may know that this formula is very, very useful. It's called the vertex formula. So by using the vertex formula, we can change this form into this form. So vertex formula is h, the vertex h is equal to negative b over 2a, and k is by input h equal to this equal into x. So substitute x equal to h into this, we will get the value of k. The most important thing is why we need to do this. Why we need to rearrange and change the form like this? Because the wonderful thing about this new term is that h and k shows us the vertex, that is the lowest point or highest point of a parabola. And also because the curve is symmetric, we can draw the graph more easily, right? So, and h shows us how far the curve has been shifted from x equal to 0. So if the original function graph is like this, h is how many units to the right, and k is how many units down. For example, if the graph is fx equal to this, we can use the formula here. First, we note down a is a, b, c value, right? And then use the formula, we can calculate h is equal to negative b, b is negative 12, and a is 2 divided by 2. We have 2 times 2, yeah, b, 2 times 2, we have h equal to 3. And by substituting 3 to here, we have f3 equal to negative 2. So by this rearrange, we find out the vertex. So now it's become very easy to draw the graph. So we can now plot the graph, right? So finally, every question will come to an application one. So let's look at real-world problem. The height h meters of a rocket after it's fired vertically upward is given by this parabola, by this quadratic function. So the question is here. And the first one, how long does it take for the rocket to reach its maximum height? So as you can see, h is a function dependent on t, and in this chapter we have learned the quadratic function. So square means quadratic, right? And because the value in front of t square is negative, so we know that the shape should be open downward. So it's open downward parabola, it must have a vertex or a maximum point. So we use the formula x equal to negative b over 2a. So here b is 100 and a is negative 5. We can find the vertex where t is equal to 10, the x-coordinate of the vertex. That means when t equal to 10, it reached the maximum value. This is t, This is h. And the second, what's the maximum height? So the maximum height is just by substitute t equal to 10 into this function. We have the maximum height is 500. And lastly, how long does it take for rocket to fall back to Earth? So the rocket open upward, then downward until it reach the ground. Reach ground means the height equal to 0. So we can put 0 here into y value and solve. We find t equal to 0 or 20. So 0 is the initial point and t equal to 20 is the end point. So the rocket back to the Earth when it's 20 seconds. Okay, thanks for watching.